Hello, welcome to this session of Understanding Analog to Digital Converter ADC. First we will discuss about a single channel ADC, which is ADC 0804, which is very widely used if it's a single input which has to be handled. This got some standard connections in R and C that decide the clock frequency, and the clock is given at pin number 4, R is given at pin number 19, that is the clock R, and this is the clock in, and the capacitor is grounded, and then we have made a typical arrangement here for the purpose of testing. It has got 8-bit output, of course one is LSB and one is MSB, and 5-volt supply, and then the digital ground, pin number 10 is the digital ground, and pin number 8 is the analog ground. And then the pin input V in, this point can also be made ground. V reference by 2, that means if the reference voltage, the supply voltage is 5, this point is internally developing a 2.5 volt here. And the start switch, we have made an arrangement in the simulation software which we will see that how the data is transferred, that means from the analog input is converted to digital and transferred into the digital output. For the other type, which is a 8-channel ADC, the only difference that it has 8 inputs. It can, instead of 1 input, it can handle 8 inputs in a multiplexing mode. What is multiplexing mode? We have an address line of ABC, that is ABC. If ABC, all three are low, it will accept the input 0 only, the analog input 0, at input 0 only. If it is low, low, high, it will accept the input 1 and input 2 and so on. That means if we keep it on a multiplexing mode, first this, next this, next this, next this, and then it goes on in sequence continuously, and the input will be scanned from input 0 to input 7 accordingly, and the digital output is developed at the digital output. This will be more clear once we go over to the simulation part of it, and we see this is what the 0804 is. In 0804 we have got the digital output, supply voltage, ground is internally connected, we have not shown here, and then V input is given here, and then the ground, it is the negative point, and the positive point we have made an arrangement of a varying voltage here. We have made an arrangement of a varying voltage here, and as far as discussed is this reference by 2 will be the half of this voltage. If this is 5, reference by 2 will be 2.5 volt, and clock resistance is 10k, and then the capacitance is connected to the ground, ranging from 100 pf to about 56 pf, which is connected to the clock in. And the other arrangements we have made only for the purpose of testing. However, these connections will be coming from the microcontroller in a programmed way for the program execution. We'll see how it works. Now once we have an arrangement like this, when the input is about say 5 volt, the input is given 5 volt, and we see the digital output is 111111. This is what the 5 volt is. Now supposing now I change it to say 4.5 volt and see what is the digital output. The digital output is like this, and if I change it further, I find the digital output is like this. Further, digital output is like this. So it goes on changing, and this digital output is taken to the microcontroller for processing further for the purpose of display, control, whatever as per our program. So this is how, and when we bring it down to completely maybe 0, and then this voltage, input voltage is now 0, and then we find the output is also 0. So this is what a single channel works. Now supposing we go over to a multi-channel, as we discussed, we go over to an arrangement where it is called ADC 0808. ADC 0808, ADC 0808, as we discussed, has an address line of, if we go over to the address line, this is that address line. Okay, so if you go over to this address line concept, this is that address line ABC. If it is 0, 0, 0, then the output will be accepting input from this only, and if it is 0, 1, 0, it will be accepting as per the table that we had seen. So now if we operate this. The other arrangements remaining same. The clock is developed by a schematic figure arrangement here for the purpose of simulation, but however this clock can come even from the microcontroller. Not necessarily that we should have an external clock arrangement. We can always program, we can write the program to send the clock, which is about 640 kilohertz. It works, so we have to develop that when we operate in the microcontroller manner. Now if it is in this manner and we see what is the input, okay, we take it to the an arrangement here. We find this is the input, this is the output. Now we change this, this is the output. We change it, and this is the output, and this is how a 8-channel operates in the address line. When the address line goes over from 0 to 1, the data is transferred, and it is accepting from the 1, and accordingly as per the table it will accept from 2, 3, 4, 5, 6, 7 as per the requirement. Thank you.